sine theta. I think it's all about first free body diagram. This is N1, M2G, normal reaction from the ground. N, let me write it here. How the friction on the block, on the wedge, you have to show it here. Now, net force by the on the system along x-axis, n1 sine theta, n1 sine theta, f cos 0. So we can apply conservation of linear momentum, but we can't apply conservation of mechanical energy. Any reason?
Non-conservative force, friction is acting.
The friction is acting.
Friction is acting.
Because of friction, we can't solve the problem. But he has asked how to find out the velocity. For that, what happens? You should calculate the acceleration, then what distance it has moved. From there, you have to get into the picture. If this was smooth, okay, then go for conservation of linear momentum and conservation of mechanical energy. Momentum is conserved, there's no problem with that. But what is the problem is mechanical energy is not conserved because of friction. Okay, sir. Okay, how to do that one? So we know this will accelerate. I'll do one thing. I need two diagrams. No. So accelerations will show it. Let's keep that diagram, original diagram as it is. Here we'll show other things. Now getting to things. Already we had such discussion in the laws of motion chapter. Now the acceleration of the block with respect to wedge AR, acceleration of the wedge BA2. Then I should bring a pseudo force. Why pseudo force? Because we are describing the motion of the block with respect to wedge. What is AR? AR, we are assuming it. Acceleration of block with respect to wedge. And then what are the equations of motion we can write it? First of all, what is normal contact is needed. So this N1 plus M1 AR sine theta minus M1G cos theta equal to 0. Now it's a good question for learning. Lot of things are involved. Okay, we got N1. Then let's write some equations of motion for the motion of the block along the incline. For block along the incline. So what are the equations are right? M1G sine theta plus M1 AR cos theta minus friction equal to M1 A2. Some correction is there. Here. I think. And that pseudo force one, I'll show it separately. Okay, no. M1 A2, no pseudo force, not M1 AR. Symbols. This one. Okay, this is our equation. What is F? F equal to mu N1. N1 equal to M1G cos theta. Okay, then this is for the block. Next for the wedge, we'll write equation. Just it's a patience student will such numericals what happen you are going to learn multiple concepts, you're not one two. That's an advantage. Now look at the wedge. What is the force? N1 sine theta will act. Then on the wedge, F cos theta. Friction also you have to show it here. F cos theta, N1 sine theta. What is F? Mu N1 cos theta. Here N1. What is N1? N1 we have from the formula N1G cos theta. These are the equations. These are some primary equations what we have, keeping it. What are unknown things? I think we got expression for A2 here, am I right? You can check it here. I got expression for it. That A2 I'll substitute here. I'll get AR. It's very lengthy. I gave the values, so we could have substituted values and solved it. Okay, I got this one. So now what should I do? From equation 2 and 3, what are unknown things? AR and A2. Yes, we can solve it. After getting A2, then I'll come into the picture. What is AR? AR is the acceleration of the block with respect to wedge. I am asking you acceleration of center of mass. So what is needed for you? Acceleration of this block along X, along Y. How to calculate acceleration of block with respect to ground along X, along Y. I'll take help of relative velocity. So if this is the block, E2, that's all, no? Here. Now what we can write here? Because what are the forces acting? This is very important. N1, N1. Friction, the friction. So in simplest thing, can we write here like N1 sine theta minus F cos theta equal to M2 A2? N1 sine theta minus F cos theta equal to M2 A2. Similarly, N1 only, symbol N1 sine theta minus F cos theta equal to M1 A1x. Are you looking at the motion of the block? So therefore, from here, what I can do now? M2 A2 in fact equal to M1 A1x. Do we know A2 there? Yes, I have A2. Okay, there's a problem solved. How to, after bringing A2, then you are going to bring the A1x also. So what is A1x? How to bring A1y? AR sine theta. I think from AR is what you have calculated. So A1y should be equal to AR sine theta. Then what is the acceleration of center of mass? You are going to write now M1, M2, A2 bar. You see very interesting things will land up. Minus this will be plus M1 A1x I cap plus M1 A1y minus G cap by M1 plus M2. M2 A2 is equal to M1 A1x. Already we have this equation. So substituting that, finally which is equal to minus M1 AR sine theta, because what is A1y? A1y should be equal to AR sine theta, J cap by M1 plus M2. So what is AR? AR is from here only we had. Substitute that, you get the acceleration of center of mass. So how the center of mass will move? It will move vertically down here. Though the block and wedge are moving horizontally, the net displacement of center of mass is along y-axis only. Even let there be a friction, with friction you can manage here. There's like a very important students here to learn things I brought it here. Okay, after getting acceleration of center of mass, how to calculate the velocity of the blocks when reaching it, because you know it will descend an height h. Remaining all you can apply it and calculate the things. How to write various equations, and finally look at the, because the net force on the system along x-axis is 0, that's why the center of mass will move only along y-axis. And what is that? This m1 m2g normal contact is also acting. You see that f sine theta, n1 cos theta, n1 cos theta. This is unbalanced forces there. That's why they said m1g, m2g, and n. This f sine theta will nullify. n1 cos theta, n1 cos will nullify. But m1g plus m2g minus n will become unbalanced force. That's why center of mass will accelerate. So what is the conclusion in this problem now? What is the conclusion? Net force along x-axis 0. That's why the center of mass will shift down. So earlier it was here, somewhere here. After some time when the block reaches bottom of incline, it will come somewhere here. Any doubt if you have here, you can clarify it. You have to substitute all the values. I just gave only the basic idea. So I think let's not bother how to solve such numericals approach. First, read the question, understand what all he has given. Show all the forces are acting. Under action of forces, how do they move? Then once again go back and read question. What he is asking? What are the known things? What are the unknown things? Then how you can write the equation. So what is the, again, very essential conservation of unit of center of mass? Free body diagram. Show forces acting on the system. What are all forces acting on the system? And check net force 0 in what direction. Conservative forces, non-conservative forces. Can I apply conservation of mechanical energy? Can I apply conservation of Newton? Like that is what happens. Student has to analyze here. Shall we
Sir,
call? Yeah.
sir, here, I have been not taking AR, sir.
Where yeah.
Sir, relative acceleration of block with respect
That
to it, sir.
that only I did know. Where you are looking at the screen. What is AR? AR is acceleration of the block with respect